Okay, so the first thing about a radical here is what are restrictions. So we learned about this word last time, restrictions.
You didn't give me a notebook.
Did I accidentally give somebody else a double notebook? Miguel or Hope, did I accidentally put 2 in yours or somebody else today? Did you get 2 notebooks? Somebody must have gotten a double notebook out there. If anybody has 2 notebooks, let me know. Okay, so this word restrictions, okay, we learned this last time with the rationals unit. It was something we can't do. So in rationals, last unit, the thing we couldn't do was divide by 0. That's what we were focusing on, okay? What do we know about square rooting? What can we not do when we square root? Can't square root a negative number, right? Okay, square rooting a negative number. Okay, can we square root 0? Yeah, that's good. Okay, can we square root anything above 0? Yeah, that's good. Okay, so we can't square root a negative. Okay, so we can do 0, we can do positive, but we can't square root negative. So we're going to focus on what makes this 0. Okay, what value makes this 0? If x was 7. Okay, just write that, leave a little blank spot in between. Okay, now, should I pick numbers higher than 7 to keep it positive or lower than 7? So think about higher. Would it be okay to have an 8, 9, 10? Yeah. Would it be okay to have lower? Would 6, 5, would those be good? No. So I want to keep it above or on 7. Does that make sense with the inequality? Do you understand there's multiple things here? Not just one number. There's multiple numbers that we have to worry about. So we want to either say we're higher than 7 or on 7. Okay, here we go. X. What number keeps this radical 0? -5. Okay, now which direction would be good? Picking numbers bigger than -5 or smaller than -5? Bigger, right? So something bigger than -5, -2 is bigger. Is that okay? -2 plus 5? Yeah, that's positive. X, 0 this time, right? 0 would make it 0. So which direction do you want to go? Do you want to make sure we're positive by being above 0 or below 0? Above 0. Okay? Or equal to 0. Okay? Because why? I'm allowed to be equal to 0 or I'm allowed to be positive. I'm allowed to be both things. Okay, what number for x would cause a 0 in that root if x was 8? What do we want to be compared to 8 to make sure we're staying positive? Do I want to be bigger than 8? Not this time, okay? Because if I'm bigger than 8, like 10, what's 8 subtract 10? Negative. So I actually want to stay below 8 this time. Okay, below 8. So 7. 8 subtract 7. That's good. Okay, so inequalities there. I'm not sure on my key how I answered it. I also would accept this notation. X cannot be less than 0. If that makes more sense to your brain, that means the same thing. X has to be bigger or equal to 0. This says x cannot be less than 0. It means the same thing. Okay. Adding and subtracting radicals. So this is doing math with like terms. You can only combine roots with the other same roots, just like you can only put x's with x's and y's with y's, collecting them together. Okay, so when I look at this, I see some square roots of 3's and more square roots of 3's. So I can put them together. So if you had 2 root 3's and you took away a root 3, now we have one of those root 3's. And these are also the same as each other. If we had 6 root 7's and 2 more root 7's, they can be put together as 8 root 7. Okay, some of the wonky things I might see is people trying to turn that into like root 14s, like adding the roots together. Okay, just think about that root like a variable, right? 6x plus 2x makes 8x, kind of that idea. Okay, here I can put the 4 root 5's with 3 more root 5's. I can also put together some root 7's with more root 7's. So there's 10 of them, and then I took away 2 of them. So that's 8 of those root 7's. Okay, and then there's this plus 4. It can't go with anything else, but I have to bring it along, right? Okay, multiplying radicals. So if you have the square root of 11 times the square root of 33, or sorry, of 3, that makes the square root of 33. Okay, now this is called a mix because we have a whole number part and a radical part. So you can't mix and match. You can only multiply whole numbers with whole numbers. So that makes 8. And you can only multiply radicals with other radicals. So that is a root 18. Okay, so you're keeping them separated in your brain. Number 3, what's the whole number part that we see? Well, just a 5. What are all the radical parts that you see? 7 times 8, so root 56. Okay, the last one, if I look at the whole numbers, I have 3 times 2, so 6. And then I have root 10 times root 10, which is root 100. Okay? I'm not going to leave that alone, though. There's stuff I can do to root 100. The square root of 100 is whole number 10. And now that I've turned it into a whole number, I can put it with this whole number. So that becomes 60. Okay, so during this unit, you should be pretty sharp with your multiplication facts. Okay, all of your perfect squares, do you have those in your brain storage? Okay, 1 comes from the square root of 1. A 2 is a perfect square of 4. Can you rip those through really quickly? Do you know them off by heart? Okay, so the perfect numbers are 9, 16. Keep going. Okay, so 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Did you get them all? Okay, so this is something you've done in grade 10, breaking down a radical. So what you're going to do is you're going to think about a number that's a perfect square. What does 32 divide by? Which perfect square can you divide 32 by? So any of these numbers, does it divide by 25? No. 4, okay, it does. But it divides by a bigger one, 16. Okay, so I'm going to try to pick the largest one. Okay, if you did the 4, you're going to have to break it down twice, and I will show you that after. So what is 32? 16 times 2. Okay, so what is root 32? Root 16 times root 2. What does the square root of 16 turn into? Just a whole number, 4. Root 2. Okay, so let's pretend I picked 4 instead of 16. You don't have to write this down, but I'm going to show you. Okay, so you would have had that 2 root 8. Okay, but guess what 8 does? It breaks down. So 2 and then 8. So that's how I would break down 8 yet. And then that would turn into a 2, and I end up with the same answer. Okay, way more work though. So that's why you're going to try to always pick the largest one, because you don't want to have to break something down and then break it down again. Okay, so 300. Do you have a perfect square? 300 divided by 100. So 100 times 3 is 300. Therefore, the root 100, root 3 is root 300. Then I know something good about the square root of 100. 10 root 3. Does this ring a bell? Do you remember something like this from grade 10, now that you've seen it? Okay, so the square root of 20 is next here. So 20 is divisible by the perfect square. 4 times 5. Do you notice how I always write the perfect square in the front? I like that in the front. Okay, but there was already an existing 6 whole number, so I better write it down still. My next move is going to simplify the square root of 4. So a 2. And then the last step is putting the whole numbers together, right? There we go. Do you want to try the last one on your own here? It's the exact same format as this one. Break down the root. Okay, change the perfect square part. Okay, so my first step is I'm going to go 75 breakdown, 25, 3. Next line, I'm going to change the square root of 25 to a whole number. And 10 becomes the front now, coefficient. Okay, does that work out nicely? Is that what you got? Okay, we're gonna either do 5 or 6 today. We'll save one for tomorrow. Do we have a preference? Which one you want to do today? Okay, I'll do 5. Okay, so we're gonna break them down. So let's start with the 20. We actually just did this one, right? 4 times 5. So focus on the root 4 part, change it to a 2. Okay, check, are we good? 6 root 5. Which perfect square are we picking for the 48? 16, okay? And it's a tricky one again because if you had picked 4, it would have been 4 times 12. But would you have recognized 12 is also breakdownable by another 4? Right? So 16 times 3 is 48. Okay, 20 root 3, check. 45 is the magic square of 9, right? 9 times 5. So focus on the root 9. Good, minus 18 root 5 was the check on that one. Okay, last one is root 12. So 12 is breakdownable by a 4. So 4 times 3. So root 4 times root 3. Okay, so 2 root 3. Okay, we're not done. Because what am I going to do to simplify this? I'm going to put root 5s with more root 5s together. So 6 root 5s, and then I take away 18 root 5s, leaves me with and the same thing, we have 20 root 3s, and then we add 2 more root 3s. Okay, so this is nothing different. You're just going to combine 2 things from the past now that you know. So when you do a monomial times a binomial, this is your action, right? You just times those, then times those. Okay, so what are you doing? Whole numbers with whole numbers, roots with roots. So together, this would make whole number 8 root 15. Do you see them? Whole number 4 or 2, so 8 root 15. And then in the next distribution, we'll create a whole number of just a minus 4. And then the 2 roots together are 21. Okay, I'm going to skip that one. We'll save a couple for refreshers tomorrow. Okay, this is the same thing. It's a monomial, so you're going to have to distribute it. It's just that it's division instead of multiplication. So you're going to have to say this divided by, this divided by, this divided by. Does that make sense? It's the same thing as this distribution. We were distributing this multiplication and this multiplication. Okay, so we're going to distribute the division. Okay, here we go. Whole number 11 divided by whole number 2. Okay, that's not perfect. Do you guys want me to do a decimal or a fraction? Okay, it doesn't matter. You could write 11 over 2 or 5.5. What is the root division there? A root 33 and a root 3 make root 11. Middle distribution. So now the second term has to get divided. So look at the whole number divided by the whole number. So 4. Root 12 divided by root 3. Root 4. And then the last becomes 16 divided by 2. So that's a subtract 8. Root. There's a 27 and a 3, so root 9. Do you think I'm going to leave my answer like that? No. Okay, so here's what I'm going to do. I can see that perfect square root 4. I would never leave that on my test. That's a whole number 2. So that actually was just a whole number 8. And I would also not ever leave a root 9 on my page on a test. So I would change that to a whole number 3. And then it can become a whole number 24. Okay, let's jump down to number 6. Okay, what does squaring mean? It means multiply something again by itself. Okay? Does it mean to multiply this thing and this thing? No. It means to multiply this family by this family again. So how does that look? That's what it looks like. Okay, I get a mistake a lot. We just did this on our last test. Are things individuals or are they families? Right? Those are two different things in math, right? This is a family, so we have to treat it like a family of repetition. Okay, what kind of math do you think I'm going to do on my next step then if it looks like this? Binomial, binomial. Yeah, exactly. We're going to have to do all those components of the FOIL. Okay, so first up, a root 5 times a root 5 makes the square root of 25. Outside, there's a whole number 4, root 50. Insides, that's actually the same thing, right? 4 root 50. And the last, this has a 4 and a 4 again, so that's 16. Root 10 make root 100. Okay, there's a bunch of stuff I'm not going to leave though. So here's what's going to happen. The root of 25 can be simplified. So that's just a 5. Oh, we have root 50s and more root 50s. So 8 root 50. Also, root 100 can change to just a 10. So that's 160. So I can say 165 now there. That's a simplification. And I'm not going to write 8 root 50. Do you see why? I can tackle that. Why can I tackle it? Because it can be broken down. Okay. How can you break down 50? Root 25, root 2. So on your test, you're going to have these instructions. Make sure everything is simplified. Okay? So that's that. If you leave a root 50 on a test, okay, I will have to deduct you because it's not simplified. You're going to have to break that down a little bit. Okay, so some of you might have noticed this, the root 5 times the root 5. Okay, and then we turned it into the square root of 25, and then it turned into a 5, right? So do you understand when you times a root by itself? It would be kind of the same thinking as that, right? And then what happens when you repeat a square root like that? It just turns into a 5. So I could give you something crazy. So if I did the root of 116 times the root of 116, it's 116. Okay? So I don't care if you are a person who does that and then that, a two-step process, that's okay. If you're also a person that just does that in one step, that's okay too. They're both good ideas, right? Okay, we're going to finish out on this one. Okay, so we're going to FOIL this. Okay, binomial becomes a FOIL. So I'm going to go 25. Okay, now this is a root 9. Do you want me to write it, root 9? Or can we just already change that into just a 3 without the root now? Does that make sense to you? Root 3 turns into whole number 3. Outside, minus 5 root 21. Insides are positive 5 root 21. And then last, I have subtract. Root 7 is root 49, or just perfect 7. Hey, what happens to minus 5 root 21 and positive 5 root 21? They're gone. So this is 75 subtract 7, which is 68, would be the final answer there. Okay, so tomorrow we're going to have to work with that. That is a special FOIL. And these things are called conjugates of each other, so you're going to hear that word from future math. Conjugates. What do you think the definition of a conjugate is when I have these two things in there? Those are conjugates of each other. What do you notice what they look like? They look like the exact same first item and second item, right? But the only difference is a plus minus. Okay? So what do you think we can conclude always will happen when there's conjugates? Okay. Do you know what else this is similar to? What does that look like? We've done lots of factoring like that. Difference of squares. Okay? Do you notice how there's just nothing in the middle of that, right? This is why. There's just nothing in the middle. Because the 3x subtract 3x, that's always going to disappear when you have conjugates. Differences of squares, that's a conjugate of each other. Okay? So we're going to keep working with that, but I'm going to call that FOIL the FLA FOIL, because I already know I can kind of cheat on that, right?